should know from last year, just to make sure that we're on the same page. So first of all, we're going to talk about points, plotting points on the scatter diagram. Now, when we're talking about the scatter diagram, we are talking about two variable data. We've finally found the two variable data, or bivariant data. So that means that you have two separate variables that are being compared to each other. So what we're trying to say is, does y vary as x varies? How does y vary as x varies? Now, key point here is that you will never join up the dots for a scatter diagram. It is not, you're not trying to find a function, you're just trying to see how one variable might affect another. So in this case, what we're talking about is that x is 2, y is 4. So you have a coordinate 210, and you can see that that point has been plotted here. If we look here, x is 11, y is 2, we have a coordinate 11, 2, and again, this is plotted here. So we have 2 points that have been plotted. Having drawn the diagram, we might want to look for correlation. And correlation describes the relationship between the two variables. So you might have words like strong positive correlation, where as x increases, y increases, and you could draw a line quite happily through the data and find that as the line of best fit. You might have strong negative correlation, which just means as x increases, y decreases. Or you might have very weak correlation, or you might even have no correlation, that x has no effect whatsoever on y. Now, something that has no correlation will look like this and very messy. You might also have perfect correlation. And if you have perfect correlation, what happens is that it will be perfectly on your line of best fit. All the data would be perfectly on the line. So previously, you've been asked to describe the correlation, and you would use words like positive, negative, or no correlation, and words like strong, weak, or moderate. So that's a pretty wide group. The second thing you might have been asked to do previously is to draw the line of best fit by hand. So this is normally drawn by eye, and it must pass through x bar, y bar, so the mean of both points. So if we look at this example, and again remembering that the line of best fit should pass through x bar, y bar, I just happen to have calculated beforehand for this set of data x bar, y bar. So this would be x bar is 7.9, y bar is 5.6, so somewhere like this would be the point. So I have to add an extra point to make sure that I can put my data through it. And then finally, we just take a line, and with our ruler, we try and draw a line of best fit. A good measure would be to check on how many points are on either side of the line. So here I have 1, 2, 3, 4 on this side of the line, 1, 2, 3, 4 on that side of the line, and it passes through x bar, y bar, so that would be considered a good line of best fit. So the difference between what we've done before and what we're going to do now is that in the past, what we've done has been not particularly accurate. So you've described correlation and you've drawn a line of best fit by hand. What we're going to do now in the IB is we're going to do the same things, but we're going to do them precisely. So instead of describing correlation, we're going to find the correlation coefficient. Instead of drawing a line of best fit by hand, we're going to calculate the regression line of best fit.